Yeah, so our first speaker is John Kenny. John is a retired computer programmer, and since retiring, he has been a volunteer with many outdoor organizations. For the past 15 years, much of this time has been spent along the Berkeley shoreline, observing and encouraging native habitat. So, John, I'll pass it to you.
Thanks, Emily. The project I've been working on is in McLaughlin Eastshore State Park in Berkeley, and it's managed by the East Bay Regional Park District. The area we've been working in is called the North Basin Strip, and it's all landfill near the edge of the bay. The Park District is currently planning the North Basin Strip Shoreline Park Improvement Project to formally develop this portion of the park. Our revegetation project started in a very small portion of the upland area of the fill, immediately adjacent to the bay. And over time, it has expanded north along the edge of the uplands for about 300 yards in roughly the area between the two arrows in this photo. Prior to 2011, volunteers with Friends of Five Creeks had been working in the area and nearby for many years, removing invasives. I started volunteering in this area in 2011, and what I'm talking about today is the process of revegetating the shoreline strip where we've been working since that time. There were a number of challenges to working in this area. For example, there's very little native seed bank other than coyote brush. There's a huge and varied invasive seed bank. By 2011, some of the most prevalent invasives remaining along the strip were radish, fennel, hemlock, and harding grass. There's no fresh water source nearby. Soil conditions in the fill are extremely variable, and we were limited to using hand tools, so large-scale vegetation removal or mowing was not an option. Next slide, please. We purchased most of our plants for the upland revegetation from the stock of local native plant nurseries. Since this location is a very urban, developed area, there are no large native plant populations nearby that we could use as a model for vegetation or a source of seeds. So we tried to choose species that were common in the East Bay Hills and sourced from as nearby as possible. We planted as diverse a collection of species as we could find. Probably about 40 or so have persisted and are spreading to varying degrees. In 2011, a small upland area just above a small salt marsh at the south of the strip had been cleared and planted by Friends of Five Creeks volunteers. Several of us began returning to this area regularly to keep the recent plantings from being overrun by returning invasives. When there was less work to do in the revegetated area because plants had grown larger or the annual invasives were in their off-season, we began to clear an adjacent section to the north and did some planting in that area in 2012. One thing we discovered in our early plantings was that big and small species didn't play well together. Large shrubs like coyote brush and sage tended to outcompete smaller natives like yarrow and bee plant, and the shrubs also grew tall enough to block views of the bay. In 2013, we began clearing an area just north of where we had been working that had no coyote brush and tried planting only low-growing species, both to increase the species diversity and to provide views of the bay. In the photo here, there's a mix of small to medium species with good views of the bay. Next slide, please. As we've moved to the north with the plantings, we've continued this general strategy of planting low-growing species in sections with no coyote brush and large shrubs and vine-like species where there's pre-existing coyote brush. In this photo, there were some large coyote brush present, and we planted some other shrubs along with manroot and honeysuckle. The bay is just a few feet behind these plants. It's not visible, but we have pretty good species diversity. In some places, we discovered that there was native salt grass that extended along a slope into the upland areas, with invasives extending partway down these slopes. and we decided to try to clear and revegetate the upland area above the remaining stretch of shoreline that was not ripraped in order to give the salt marsh plants more room to spread. In 2016, we began a monthly volunteer work party at the site. We usually had about 8 to 10 volunteers, and these regular sessions enabled us to clear the shoreline strip more quickly. Next slide, please. At one point, we came to a section with a large pre-existing patch of Elymus triticioides. This turned out to be a mixed blessing. On the plus side, there were fewer invasives to clear in this section, and we didn't need to do any planting. It also grew tall enough to discourage social trails, but stayed low enough to preserve views of the bay. On the minus side, there's not much native species diversity, and the perennial invasives that are mixed in with the Elymus have been very difficult to eliminate. When the pandemic began in 2020, we stopped doing our monthly work parties. By that time, the large patches of invasives had been cleared, and since then, a small group of longtime volunteers has monitored the area for persisting invasives and tried to encourage the spread of the new native seed bank to fill in the remaining gaps. Next slide, please. Over time, we've begun relying more on passive revegetation to expand the area of natives. Many populations will gradually expand either vegetatively or by dropping seeds nearby. Some species produce abundant seed which can be scattered in locations with few natives or low diversity, and over time we've found an increasing number of species reproducing. Some of them have taken a while to get going. For example, we planted some soaproot in the early years, which flowered and set seed for at least 5 years before we saw any seedlings, but now spreads vigorously in some locations. We've also recently found western goldenrod, Euthymia occidentalis, which is common in a nearby restoration and appears to have migrated into the North Basin revegetation area. Next slide. The ongoing challenges we have are mostly in the areas where we have low-growing species. The area is open to the public, but there are no formal trails, so people often walk in places with little vegetation. This photo is of a section where the main trail is very close to the bay, and people walk over to look at the bay, which prevents seedlings from getting established. Next slide. Now that we've removed most of the large invasives in this section, annual grasses are a bigger problem. They're usually outcompeted by the shrubs and even by dense stands of the smaller natives, but it's hard to get plants to spread into the grassy areas. Things like oats and small festuca grow very densely and start early in the season, and if you pull them out, you're likely to pull out any native seedlings as well. Next slide. Some things have worked really well over the years. Since this was a long-term project and we didn't have to stick to a fixed schedule, we were able to start slowly, work in phases, and adapt as we gained experience with the local conditions. We could also dedicate time as necessary in the years following planting to work through the invasive seed bank in previously planted areas. Large native species have expanded fairly quickly and have been very effective at minimizing reinvasion. There seems to be a growing native seed bank, and passive revegetation has been increasingly effective. Timing planting with the rains has worked really well. Once they're established, plants have done well without supplemental water. Next slide. There are still many ongoing challenges. For instance, small species are difficult to establish and less effective at resisting reinvasion. It can be very labor intensive to try to maintain these populations, particularly without mowing. Most annuals have been difficult to establish. In addition to all the other small species problems, seedlings are often eaten by snails. Oxalis can become an increasing problem in areas with low-growing species. Small infestations can expand quickly if they're not addressed. In years with little or erratic rainfall, supplemental water greatly improves the survival rates for some first-year plants. The lack of nearby water makes it difficult to do this at any sort of scale. And in general, scaling up the project area would require changing some strategies and using more efficient methods of initial invasive removal. But given the large invasive seed bank nearby, there will be a need for long-term monitoring and removal of invasives after an initial revegetation. And much of this long-term monitoring and invasive removal could be effectively done by volunteers. Thank you, and I'll take any questions.